Hello, welcome to Geomet Puzzles YouTube channel. One example you can see on a screen, and this example mostly asked in class 10 Maths Olympiad and the NTSE exams. The question is ABCD is a quadrilateral and one circle in between this one, so that the AB is a twice of the CD. Here the given data, and AB is parallel to the CD also, and AC, this AC is perpendicular to CD and AB. Okay, so here one right angle, here right angle. Okay, and ABCD, this complete quadrilateral have the area 18 square unit. Now we have to calculate the area of the circle. We have to calculate, and for this one we require the radius of the circle. So from the center of the circle to the tangent, this AB is a tangent of the circle at this point, AC is a tangent of on a circle at this point, and CD also a tangent on this point on a circle, and DB also a tangent on this point. So every tangent we will draw like this one, and which is a right angle. We know the tangent is always be right angle to the radius. If we draw from the center to that point, that makes the right angle. So these lines we will draw, which are the right angle, and from the D parallel to the AC we will draw a perpendicular like this one on AB. Perpendicular means here the right angle, so we will get one here the triangle. Okay, so let's see this F. So this F is we got, and we already fair these lines, so we know these are the right angles. So this is radius, this is also radius, so let's say the R, radius R for the radius. This is also radius from this to this center, and this is also the radius. As we know, this is the A side, means we can say AB is the A side, and this is a twice of the CD. Okay, so AB is a twice of the CD. So let's see, the CD is a A, so twice of the CD means twice of the A. Now this is the radius from this point to this point, and this point to this point also radius, means AC is a twice of the radius. This is also the radius R from this point to this point, but here is the 2A. So we can say this A deducted from this 2A means from F to A is, if we are subtracted from 2A, this FB comes the A, means FB is equivalent to the CD. Now this is comes the A. Now this FD we know 2R, this FD is 2R. Now as per the tangent and the circle, if we draw any tangent, sorry, this figure is not much correctly, so let's assume this is a circle. From the external any point, if we draw the tangent makes the right angle to the this radius, and this radius are also equal from this point. So as per this fundamental of the tangent and the radius of the circle for the exterior point, so these 2 points are equal from this point, because this is a circle. Here also these are the equals from this point, from this point. So this is a R, this is also R. So this is a minus R. As this is also equal, so this one comes the A minus R, means from this point to this point. So this is a minus R. Now from this point to this one, and from this one to this one, this is a one point which is making the right angle or the tangent right angle at the circle here and here. So from this to this and this to this are both are the equal. So this is, we know, 2A minus R from this point to this point. So this one also 2A minus R from this point to this point. So now let's concentrate on this triangle FB and FD, this angle is a right angle, and DF is this side, which is A minus R and 2A minus R, addition of this one. Let's apply the Pythagoras theorem. As per the Pythagoras theorem, the hypotenuse, this one, is the square of these two sides additions. So A square plus 2R square means this side is equals to this plus this means A minus R plus 2A minus R bracket square. So A square plus 4R square is equals to, this will comes the 3A minus 2R bracket square. So here 9A square plus 4R square minus this 3 2 the 6 multiplied by 2, so 12AR. So here the 4R square plus A square. Now both these terms are same, so let's cancel it. So A square is equals to 9A square minus 12AR. So minus 9A square comes here and it will comes the negative, and here also negative. So let's change the position with signing also. So A square, 9A square minus A square is equals to 12AR. Now this one comes the 8A square is equals to 12AR. Let's cancel the 1A. So I just note down here 8A is equals to 12R, or we can say after the 4 removed. So this is the 2A is equals to 3R. Now this is the one equation we got it. Okay, so let's say the equation 1. Now as we know, this is the trapezoidal ABCD because CD and AB are the parallel. So the trapezoidal's area of the trapezoidal we can say is equals to 1 by 2 multiplied by this 2A this side and this parallel sides addition 2A plus A 3A and multiply by with 2R. So this comes 3A multiply by this 2R. So area we know 18 is equals to this 2 get cancelled, so it's a 3AR. So we can say AR is equals to, after this 3 dividation with 18 it comes the 6, so 6. Now we will multiply this AR is equals to, this is a one equation number 2, and equation 1 is the 2A is equal to 3R. So let's just now down here 2A is equals to 3R. Let's multiply by this equation by 2. So 2A by multiply by R is equals to, this will come the 12. Now 2A value we know 2A is equal to 3R. So put this 3R here, 3R multiplied by R, we can say multiply is equals to 12. So 3R square is equals to 12. Now 3 comes here and it will divide the 12. So R square is equals to 4. So we can say R is equals to 2. So radius is a 2. Now area of the circle. We know the area of the circle. Area of circle is pi R square. Pi is a 3.14 multiplied by this R square means 2 square. Now 3.14 multiplied by 4 is equals to 12.56 square unit. So the answer is area of the circle is 12.56 square unit. This is our answer. Thank you.